Hello, everyone. Welcome to Global Hack Week season launch. I hope everyone's doing well and having a wonderful day so far. Let's see what we're going to be up to today. Thank you. Welcome to the stream. So let me throw this up and let's see. Everyone can hear me? Cool. Sip of water. Staying hydrated when you're coding is always important. Hello. Welcome to the stream. So this is going to be our introduction to Git session. We're going to be going a few different things to get you started. Hello. Welcome. So like I said in the announcement, if you came from there, this is a really beginner-friendly lesson workshop that teaches you how to get started with Git and what Git really is. And from there, we will build upon skills, and the goal here is to really knock out your fundamentals. I know a lot of people will hear the word Git and be like, oh yeah, I know what it is, but they really don't really fully understand how it's utilized or what is it for. And we're going to explore a lot of that, as well as stand up a project if we have time towards the end and Git itself. And then we will not going to explore some of the tools, but we will go over some tools you can utilize Git with. So before let's get started, we do have some slides. Let's get started with that. So hi, everyone. So I am Kev, and I'm a coach at Major League Hacking. I use the he, him, his pronouns, and I do a lot of different things. I work with a lot of different technologies. There are some things I'm good at, some things I'm better at, some things I'm horrible at. No one can be good at everything. But if you ever want to talk about anything, please do feel free. So if you want to ever soundboard off of me, always open to lend an ear, and maybe a thought or two if I have any. But yeah. That's enough about me. Let's get started with the content. So what is the schedule overview for today? So today we're going to first go over what is Git. We're going to go over some key vocabulary words used in Git. We're going to go over Git in the cloud, as well as Git as a service. We're going to go over some Git commands, and then we'll get some hands-on time. I've got to take out setup GitHub. That's generally done at a later time. Welcome. Hello. Welcome to the stream. But yeah, it should be a really fun session. It's an interactive session, so please feel free at any time to stop me and ask me any question. Hello, welcome to the stream. And that said, I am personally I do not understand if you can code or work without music. I don't know how you do it. Sometimes I want to ask when I take an exam or any type of test of sort, I want to ask the proctor or the professor or the teacher if I can plug in my headphones. I'm not trying to cheat, but I don't know how people work without music. It blows me. But yeah, hi there. Okay, so with that being said, I am going to go and put on some music on really low for you guys, so you guys can have some background noise as I stream. I'm going to mute it myself so it doesn't go over the mic. If it's too loud, please do let me know, and we'll get that taken care of as soon as possible. Really, I can't. I need music to code. Silence would drive me nuts. But yeah, I guess everyone floats their own boat. But yeah, from there, let's get going. So first thing, what is Git? So Git is essentially a distributed version control system, which is essentially a complete code-based copy on that can be held differently. So you would generally have a remote, which is where the code base will be stored, and then we'll copy it over to multiple developer machines or multiple local machines for the code we work on. We'll later give you a visual representation, but the overall understanding is Git enables a way to distributedly control versions of complete code bases. It supports simultaneous collaboration and offline work without the risk of losing changes. And what that means is allows multiple people to work on a code base together without stepping on each other's toes. And it helps you reduce risk of losing changes because it actually auto saves things in the background. And it also keeps a fully copy of the code base, the most intact copy, remotely. So in case, let's say your computer dies, your hard drive dies, I kind of tease this a bit, like if a power outage occurs, which actually it did, my power went out maybe an hour before this stream, which was kind of scary. But Git will, if I was actually writing code, but in case, let's say something got corrupted, a copy of the code base at its most stable form will be stored remotely as well. We're going to draw a lot of this out later, so don't be too worried if you can't mentally picture some of this stuff. We'll just go over some high-level concepts so it's in your brain. And then after that, we will make sure we do a deep dive and actually see how all this works. So Git also keeps tracks of not only the file with directory, but it actually keeps track of changes at the line level, so each code line, at the file level and at the directory level. And it provides visibility into the authorship and timestamp. So it's funny because you always want to blame someone else when you're writing code. What Git actually happens, and what it does is, let's say you wrote a piece of code and you might be like, who wrote this garbage code? And if you maybe wrote it a half year ago, you can check the author and who wrote it, and it might be yourself. Happens to me all the time. It's okay. We just fix it and then we move on. Yeah, I can share the slide link. So after this presentation is done, if I can, I'll get a copy of the slide link and I'll share it with you guys. I might share a copy directly to the drive where I might make changes from time to time. So it might not be in spec state because I revise this workshop every time I run it to include more stuff, to take out things, and just roll over improvement. But I will share this workshop in the Global Hacking announcement chat after this is completed. But yeah, no worries there. And you can always come back and watch the recording if need be. Also, Git allows something called branching and merging, which allows what we call parallel development in separate code versions, which is all you have to understand from that line is it allows basically multiple people to work on a code at the same time and go from many different places. And we'll explore that a bit later as well. So what this also allows to do is developers can work on features where we call changes independently and then merge them back together into the main code base. And this is the idea we talk about remote and local development. So as a developer, I can work on something locally. And then once I'm done, push it back up to main or the remote branch. And then from there, it can get all put together into a nice final branch. And we'll go over a lot more of this concept in a visual way in a few seconds. Okay, so some key vocabulary words. I might have said some words purposefully, some might not be as purposeful as I gave some explanation right there. So key things to keep in mind is the word repository. So a Git repository is a database that contains all the files, changes for a particular project. So all you can think about a repository is essentially the Git code base for one project, right? So if I'm writing, let's say, a project like a calculator app, I would make a calculator app repository, and that will be a Git repository that would store all the files. And Git, if you think about it, you know how like when you open File Explorer, Git essentially is almost like that, but it has its own way of tracking changes in different type of files to be able to come like piece things together. So you can imagine like a piece of the puzzle, right? But instead of the puzzle only making one shape, the puzzle can make multiple shapes based off of different times of maybe when we add pieces of the puzzle, it can grow bigger, right? And when we take pieces away, it grows smaller, but it can always become a complete puzzle. And that's kind of like what a repository is. It essentially is the database or structure that allows us to be able to look at past changes, keep history, look at lines of code, who edited what, and even sometimes go back to previous iterations of our code base. And by the way, again, if you have any question, please do drop in the chat. This is a super beginner-friendly session, especially as for our season launch. So if you have any questions, drop in the chat, and we'll be more than happy to address them. So commit. So what is a commit? A Git commit is essentially... Okay, we'll go over that. You read ahead, and we will go over that. And then if you still don't understand it when we get to our visualization stage, you'll see. I promise you. If you still have any questions later on, do ask again, but I'm going to move on for now. So a Git commit is a snapshot of the changes made to the code at a particular point in time. So each commit has a unique identifier that essentially tells the puzzle, right? So it's like if I built this puzzle and I called it flower, right? And I built upon that puzzle, and maybe I added a lake. So maybe when it's the commit for the flower is just named flower, when it commit was lake and flower, that we can keep track of different iterations of the puzzle, right? So one iteration would be flower, and when I say it's flower, we'll just build the puzzle with only flower. We'll say it's flower with lake, we'll build a flower with lake, and kind of like that. But all you're gonna do is Git commit is essentially just a snapshot of the current code base at a particular time. A branch is essentially how Git works. It works as almost like a tree structure. You start with a main branch, and here's where you are, and a branch allows you to essentially, you think about a tree, right? You have the root, which is the center of the tree, and then you can branch off from there. And each branch you generally would take care as a version of the code that is created from the main code base, and that you would work on, and then we'll bring it back into the main code base. And that's where merge comes in, right? So we first have a repository. In the repository, we have a main code base or a main branch, and that after the main branch, we can make smaller branches to make changes. And as we're making changes, what we do is we make commits. And those commits will essentially save those changes onto those branches. And then we'll go over some other concept, but what merging does essentially is it takes one branch and brings it into another. And this is really important is when, let's say I made changes to a particular part of the code. Let's say we're building a calculator. I wrote the addition part of the calculator. And let's say one of us in chat helped me and wrote the subtraction part of the calculator, and we want them to combine them together. What we'll do is we'll take my branch and we'll merge it with our chat's branch. And that way our code will be combined into one, which will then offer both the addition and subtraction features of the calculator. But yeah, let's continue. Again, stop me if you need questions. And I almost forgot. Check-in link. If you did not check in yet, please do check in. We do want to make sure you get your swag. If you want your swag, if you don't, I guess everyone suits their boat. It would be lovely if you check in. I'm going to drop that in the chat. That was my apologies. I should have done that. I'm glad that helped you made a bit more sense of that. And a bit more water. Give me 1 second. Okay, cool. So make sure to check in real quick. Simple link, click on it, check in. What happens if two separate users creates their own branch and make changes that work within their own branch, but not with each other? Or does that really just not happen? That's a great question. We're actually gonna table that question. We're gonna park that in the parking lot, and we're gonna come back and visit that question. If I do forget, do remind me later. We're gonna go over scenarios what this might look like and what really happens and what we do. But I'm gonna table that for now. I'm gonna keep going over some key vocabulary, but I won't forget. Actually, I'm gonna table it so well that I'm going to, on my own computer, take a quick screenshot of that. So make sure I don't forget. I'm gonna park it in the parking lot on this side of the screen. There we go. Okay, cool. So key vocabulary 2, pull request. What is a pull request? Pull request essentially is a request to merge changes from one branch into another. So here is the key word here. There is pull can be used in multiple scenarios. Essentially what pull does is it takes a branch and either, when we say a pull request, what it does is it takes a branch and then it merges that branch into another. So the difference really between merge and pull is really slight. Pull request uses merge. Essentially, it'll take that and merge. But what pull request does is it's really similar to merge. It's hard to explain. So the best way to think about it is most of the time when people refer to pull request, they're referring to pulling from one branch into another branch and mostly to the main, right? So if I have a feature branch, let's say I'm working on that addition, right? Instead of merging directly that addition into my subtraction, with that subtraction to the addition code base for each branch, what you would do is you would have a main branch and I would then make a pull request and the request will sit there and there might be other validation checks and go past there, like let's say a code review. And our code review is another coder or developer will read over the code to make sure everything's good, and then your pull request will get accepted. If it gets accepted, then that branch will get merged into the main branch. So pull request essentially is just a fancier merge that usually happens through code cadences, or in other words, basically through the development cycle to make sure the code base is clean, neat, and easy to use. Remote. So a remote repository is basically a copy of the repository that's stored on a server or in the cloud or a machine, and that's where everyone will grab the repository from. It's solely, that's really it. It's really simple. So when I say remote, it's referring to, let's say, either the repository is stored on your own server somewhere, stored on maybe your school server, stored on maybe GitHub, and we're gonna go over a few other versions like GitHub, like GitLab, and so on and so forth. Forking. Forking is a pretty common concept, especially in the open source space. What a fork is a Git fork is a copy of the repository that is created and then owned by you. And this is really used in the iterative process, which is really powerful in open source, right? Let's say the random tuxedo from chat built a calculator, right? And he already added subtraction, addition, and maybe even multiplication, division. But I want to add more. Maybe I want to add scientific functionality to the calculator. I can fork his project over, and it depends. There's licensing and stuff like this, but most of the time, if it's open source, it doesn't matter. So maybe let's say it's open source. I can fork his project over and then build on top of his project. So I don't have to start fully from scratch. I have a jumping point, and this is real important. It's your process, right? If I were on like a cloud repository or a public repository like GitHub, and you found a project you really like, you can fork it and build upon it. You can fork it and tear it down, and so on and so forth. It's just making a copy of a Git repository for your own usage. Pull request. This is the other. This is pull. I keep saying pull. Pull request and pull are different. Pulling essentially is going to the remote repository and pulling in all the changes and merging the current branch. And the reason I was trying to say this earlier is the whole idea is you're going to a branch and you're merging it in, and there's two different pull processes. Pull request is generally when you go from a local branch and merging into the main branch. A regular pull request, as in like a pull, essentially goes to the remote location of the repository, the remote copy, and say, take the newest of that and merge it into my current local repository. And we're going to go over a lot more of that in a bit. Don't worry there. But before I actually move on, any questions from chat about anything? Does a fork go to another branch as well? We're going over branches. So is the pull opposite pull request? Okay, good questions. We'll start with this one first. Does a fork go to another branch? I'm not 100% sure what we're asking, but if I'm understanding what you're asking, a fork does not, it's not a branch. What a fork does, essentially, you can think about it, it takes a complete copy of the main code base, and then it will create it for you. So it's like if I copied a file, right? If I was a teacher and I gave you a Word document to work on, right? And I don't want you to edit the main Word document. I want you to build upon my Word document by answering the questions. You will just make a copy of the file, right, into your own computer, and then you'll work on it there, right? And forking would be that exact thing, right? So you would make a copy of the whole entire code base onto your own Git repository. So it's a complete separate Git repository, and then you would work on that, and that has no more references to the main branch you forked off of, except for sometimes people write, oh, this is a fork of XYZ. That way you can give a attribution to the source of your project. Does that make sense? If not, feel free to ask a follow-up question. I'll answer it. Pull is opposite of a pull request. It's not. Unfortunately, they named it really similarly. So a pull is just going to your remote branch and taking the latest copy in your remote branch and merging it into your current branch. A pull request is a request generally made in the software development process where you are ready to merge into the main branch, where the root branch, and you're saying, I want to take this branch and merge it in here. No. So this is different, right? I will use the word repository, right? You make a copy of the repository. You don't make a copy of the, I guess that's really poor wording. You make a complete copy of the repository. You're not making a branch to work on. You're making a complete copy, right? So once I draw this out, it'll make a lot more sense. So I'm going to actually table this question, and I'll go back and come visit that. Let me grab a screenshot of this question, and I'll make sure this makes a lot more sense once you see it. It's a lot to think about in your head without some visualization of it. The non-technical life example, like the teacher sharing documents. I'm glad that's helpful. And yes, if you have any question, please do continue asking. And I am telling you this, I've worked with people who just started in, let's say, being a software developer or a software engineer who don't fully understand how Git works. So you coming here and learning to understand how GitHub or Git works is a way step ahead of the fully understanding, and not just, oh yeah, I written Git, blah, blah, blah. It's fully understanding how the whole process works. It gives you a tremendous edge in what you're doing in the project you work on. So do bear with me if things are confusing, because it is a confusing concept. Most people don't get it even right out after they graduate, let's say a 4-year school, etc. But before we dive any deeper, and let's take a break, take a breather to let your brain digest some of that information. I want to go over some things you might see in the wild, as in the real world. So Git in the cloud. What Git in the cloud is, essentially, we talked about how Git repository can be stored in multiple different places. Git in the cloud essentially is where you would create a cloud account, and it would be stored in some cloud server somewhere with multiple backup, so it'll never go down, right? One of the really popular one, and one of which often sponsors MLH events, is GitHub. So if you don't know, GitHub essentially is a Git in the cloud service. It allows you to store Git repository on their platform and their servers. Another one that's not exactly the same, but is similar to GitHub, which you might see in, let's say, a corporate environment, or if you ever do software engineering with development full-time, is GitLab. GitLab and GitHub are both really similar. They might offer a tiny bit of feature differences, but the underlying idea is the same. It's a cloud place where they help store your Git repository for your team or people to access. You have Git Bucket, which is another thing that's really similar, so I'm not going to explain the whole concept again. And then cloud Git as a service. The reason I say as a service is you can always host your own server and host your own services on the server. That kind of does what GitHub, GitLab, and Bitbucket does. And two really cool open source projects for that. If you're ever interested, this is really way down the line, especially if you're new. If you're not, maybe something cool to look into. You can always just host a Git repository local on computer. You can always create a Git as a service place. And that way you can hold your project there. You get a whole nice login, you get a whole nice user interface, and so on and so forth. And these two you see on the screen is one is called Git T, the top one, and the bottom one is called, oh, it's slipping my mind. I should know this. Let me check. I can't remember what that symbol is called. Well, doesn't matter. If you ever just look for alternative for Git as a service, we'll come back to that some other time. But yeah, so some basic Git commands. We're gonna understand these Git commands. So as I explain them, I might attach commands things. So first, git init, which allows you to initialize a Git repository in your working directory. Git add adds changes to the staging area, and don't worry, we're going to explore all of this. Commit changes to the local repository is what Git commit does. Git status shows you a status of all the working directory and the staging area. Don't worry, if they sound foreign, don't worry about it. We're going to go over it really shortly. Git pull pulls changes from the remote repository down. Push, sorry. Git pull does that, yes. Git push pushes changes from your local repository back up to the remote. Git clone makes a copy of the remote repository into your local machine. This is not forking. We're going to go over the difference. Git branches lists all the copies or all the branches in the repository. Git checkout is what allows you to check in and check out of a branch. Git merge is just the merge command, which talks about combining two branches. These are done in what we call the Git shell. So when you install Git onto your command, when you start Git onto your computer, you can do it in Git Bash, which is just Bash with Git installed on it. You can do it in CMD, which is just Git with installed in CMD. As long as you have Git installed, just Google Git. I'll show you actually in a second later. But if you Git installed, you would just go type into any terminal and get the commands working, just like any other most applications. Okay, so now the surprise fun time. It's time to do some MS Paint, and I've been not on top of my banner. So I'm going to change this to ask me anything. Feel free to ask me anything. Could be this related, could not be this related. Any question goes. And now is the fun part for you and fun part for me is when we actually swap over to MS Paint and we explore a lot of this concept in depth. Okay, so before I do that, give me 1 second. Let me also, you might see this glitch out for a second. I just want to grab a copy of the slides to make sure I can go over all the concepts. Just give me 1 second. Yeah, have any questions, please do ask them. Let's see. So I'm going to do. Okay, cool. So this slide link is saved right here. Okay. So the first thing we're going to go over is just some key basics. And for the said key basics, I do need something else real quick. Give me 1 hot second. I'm going to pull that over here. Okay. And then I am going to pull this up. Okay. So we talked about a few different things about Git, and we're going to go over some of that. And what Paint allows me to do is draw it for you guys, and you guys can really visualize and see it, right? So the first thing we talked about is what Git does. We're going to start with the really basic command. We're going to tie commands to things to really help you visualize on how this kind of looks like. What is the purpose of the project section of Git? I don't know. There's no project section of Git from I'm not 100% sure what you're referencing. If you expand on that a bit more, my best guess you're talking about a service on GitHub. So project section, essentially what GitHub causes, they just call it projects. Each project is generally just a Git repository, right? I said that you would generally, let's say, use the Git repository for each project. I'm going to go over that right now. Thank you for clarifying that. That does help answer the question. You don't want to shut that out. But we're going to start off really simple, right? We talked about a really simple command called git init. This is the start of a Git repository. So the second you do git init, what actually happens is we start, so let's say this is your computer. This whole screen is your computer, right? Well, the second you run git init, what happens is in that directory you're in, or inside that folder you're in, what it does is it generates hidden files or hidden folders. That is what Git is going to be stored in. So it generates this, right? And what this actually just represents is the current state of your project. So I'm going to draw a circle, and this circle represents a node or a point in your tree. So here is, let's say this is the start, and we're going to call this main, right? So this is the main branch, and this is a node in the branch. So this is, let's say, a commit. Each commit will be represented by a circle. So we're going to come down here and draw this. This is equal to a commit. And the first thing you do is when you make a actual git init, it does is it creates the first commit. And this is the main branch. And each line, like circle linked by a line, linked by more lines, right? Each line, essentially, each line, this, each section, right? So like this, each section of this. So section of commits is equal, it is a branch. That's how you would think about it. So what this means is if I am working only on main without moving over to branches, right? I make a commit. This is your main branch right now. If you can't see, please let me know. I can blow this up a bit. I just want to make sure you guys can see. Let me know if you guys can't see, especially if I'm writing too small. But yeah, so this is the main branch. So let's say if I do a git commit, what happens is it creates another snapshot of the code base at that time. And so this would be, let's say, commit 1. And when you do a commit, you generally say something, right? So maybe I say git commit add feature. And this is still one branch right now. We haven't gotten to multiple branches, and you can see. So once you do git init, it makes its really first command, and this is your first snapshot of your code, which is nothing in it. And maybe I added code, I do a git commit, and that will do this. But this is not all. So actually, before you do this, we need to understand another fundamental part of Git is how it works. So there's another command we went over, which is called Git Add. And what Git Add does, it adds your files to a staging area. Yes, so we mentioned this. Git is the technology. Git is the version system control technology. GitHub is a cloud service that uses Git and allows you to host your Git repository on their service, right? So GitHub is a service that stores Git repository. Git itself is a technology that is used for version system control, which is another fancy word of saying keeps track of a lot of things and allows you to go back and do all sort of cool things. Yep, that's 100% correct. Git is just where it's stored. Or GitHub, my apologies, spoke too quick. GitHub is where it's stored. Git is the technology that GitHub utilizes. So what Git Add does is it adds in the staging area, and how you would think about it is, real quickly, we're going to explore the staging area. We're going to do this. I'm going to grab this photo. I'm going to copy this to clipboard and drop this right here. Okay, cool. So we're going to look at this photo real quick. Oh, okay. That blown up looks weird. So we're going to leave it as is, and hope you guys can see it. If not, I'm going to zoom in a bit, actually, and see if I can. Can I move? I move laterally. Okay, cool. So this is what we're looking at, right? So a working directory is essentially where your code is being worked out right now. So before a commit is generated, right? So before one of these circles is made, you are just working in a working directory, right? So let's say I am working on, let's say right now, we're going to take the whole idea of remote, right? We're only working on my local computer, because on your own computer, you can run a Git repository from your own computer. We have nothing remote. Everything is local. And this is a really good place to start understanding. So, right? So nothing is currently remote. We don't have a remote repository. This is all local. Local repository. I can't spell by the way, I'm a computer scientist. I can't spell. So this is going to just imagine that's this repository. Once I start, if you don't know, once I start squiggling my sentences or my words, means I can no longer spell it, or I don't want to bother to try to figure out how to spell it. Fun fact. But yeah, so this is all local. Pretend this is all happening on your computer. So I ran Git init on my computer. I then created this file structure that created my first snapshot of my code base, which is this branch. And Git Commit eventually lets you generate more branches. But before Git Commit, what we need to talk about is Git Add and how this actual process works. So when you're in your working directory, which is right here, right? This is the directory you're working in. You have to add files to the staging area, which is managed by the Git repository right here. And what that actually does is, let's say I wrote a file called, let's say I called it hello world .py. We're going to work in Python because that's a really beginner-friendly language, and it's a pretty good one to pick up if you don't know it. It has a lot of industry purposes. So let's say I wrote hello world, sorry. To actually add it to the staging area. Also, I do want to say if my power goes out, I will be right back. I did tell the story where I lost my power earlier. I hope it doesn't go out, but if it does, don't panic. We'll be back. Just stick around. But hello world.py, let's say I create this file. It's currently only in your working directory. It doesn't actually start being kept tracked by Git. You can think of Git as, let's say as like, I don't know how to put this. Let's say Git is, let's say, assistant, right? You can think about it. Technology just here at assistant, right? So here's me, right? And here is Git. And Git is my assistant. What happens is, let's say I'm working on documents, right? Kind of. We're going to go over it, underdog. Don't worry about it. I'm going to explain it. But let's say we're going to use this analogy. So let's say I am me, and then somehow I'm important enough to get an assistant. So let's say I'm working on a document. So I'm working on a Word document. And how this really works is I'm working on this Word document. And whenever I'm ready, I want Git to, I might hand this to my assistant and say, every time I make a change to the Word document, please make a print out copy for me. But what Git Add does is it tells my assistant that. So me telling my assistant is essentially me running Git Add in the file name and telling my assistant to keep track of this file. So if I don't do a Git Add, my assistant will be like, oh yeah, I don't know what, because I never told my assistant to keep track of it. So what Git is a technology that's lying there. It will be, once I said Git Add, it says, okay, now, from now on, I'll always keep track of this file. A better example is probably in the real world that you probably actually encounter is Word documents, right? If you use Word document nowadays, they have something that's like autosave, right? It's the same thing, right? If you can disable autosave. If I disable autosave, I'm essentially working in my working directory. If I enable autosave, what it actually does is it said, I told my Word document that I want this Word document to be saved every 5 seconds, 5 minutes, and autosave will kicked off. And what that is, the staging area, this area, is just all the documents that needs to be saved, right? That needs to be kept track of. And all the changes that needs to be kept track of in documents that we're keeping track of goes in the staging area before the commit, which then actually pushes it into a final part of the repository. So it's before we actually do a commit circle. So it's like this line. If I was to draw this line, it's not done yet, right? I haven't committed. So I'm currently working at this in this line. And what happened is, as I'm working in the directory, I would write files. I do Git Add, which is basically telling Git, hey, I want to keep track of these files and all the changes in these files. And these files, when I commit, I actually want to put them into the repository. So they're just staging area for the files, right? So I would say, okay, I want you to keep track of hello world by doing Git Add hello world. After I do that, the Git knows, let me put that in the staging area. And that, whenever they run Git commit, everything in the staging area needs to be committed to the repository. And what happens is, so what this looked like was here in the whole animated process. Here's the repository. I mean, the snapshot with the first Git commit, which is the main. We're going to be working here. I added a file. Let's say hello world. I do a Git add. So the Git knows I want to keep track of it. And then once I do a Git commit, it goes, okay, so now I take everything in the staging area and add it to this official commit. And then let's say this will be called hello world. Does that make sense? Any questions about the staging area and how this kind of all works? So you're working with a directory. In that working directory, you would add all the files you want to be kept track of by Git, and then that will go into the staging area. And from the staging area, a commit will then push it into the final stage of the repository. No, right? We're going to go over, remember, this is all local. We don't have any branches, nothing remote. So there's nothing you're pulling, right? Polling only occurs when you need to go to a remote branch and take the newest copy and pull it down. We're going to go over all of that. Don't worry, but no pulling is occurring right now. We're working on a local machine with a local Git repository initialized on that local machine. Okay, so we're going to add that. Okay, so you can just think of it as Git Add essentially is just telling Git that, because whenever you make a file, right, Git doesn't know to keep track of it, because there might be files you don't want to keep track of, right? So maybe I wrote a file that I temporarily am storing, let's say, passwords for like API keys, or like I have a file of like just dumb stuff in the same directory, right? So maybe imagine this is your directory, right? So I have other files, maybe like images that I'm like referencing. Like I have things in this project directory. So here's your project directory that you might not want to be in your actual repository, or you might not want someone else to have, right? So maybe I have like images, I have Word documents that are just meant for me. So I don't want Git to keep track of those. And to tell Git what it needs to keep track of, we utilize the staging area. So for the second, let's say I created the file called hello world, it will sit in the actual file system, right? And it will sit in this hello world file system. And Git won't know to keep track of this file, because it doesn't want to keep track of everything in this directory in case there's things you want to keep personal or to yourself. So what it does is you would run Git Add in command line, right? So you would tell Git by running Git Add, saying, I want to Git Add this file. And what that happens is it tells Git, okay, this file I don't want to keep track of, this file I don't want to keep track of, this file I want to keep track of. So it will start keeping track of all the changes made to this file. And it will keep those changes in what we call the staging area, right? So here is the staging area. So once you do a Git Add, this file will now be added to the staging area where it's keeping track of all the file changes. And once you run a Git Commit, what it does is saying, okay, here is the repository. Let me go over here, create a new commit, and then all the changes in the staging area will become permanent part of your branch. Git Add is not a placeholder. The staging area is the placeholder. What Git Add does is Git Add tells Git that you want to keep track of that file. For sure, for sure. Where is it not committed to memory, but is there? Sorry, don't forget that. I'm hoping the O means you got it. Okay, any other questions, feel free to drop them. But here is kind of like what we're working with right now, right? So we kind of now understand branches, right? So I can create a branch. I would make files, stage it in the staging area. And then the second I'm ready, I do a Git commit. It'll become a permanent part, a permanent commit of that branch, or permanent node of that branch. And we only have one main branch right now. The exception we're working with is local repository, one main branch, nothing else. Yes, you can remove things from the staging area. The staging area is just it's like a notepad that gives writing down, oh, I need to keep track of this file. I need to keep track of this file and keep track of this file. Let's say you want to remove something from the staging area. You can remove something from the staging area. That gets a bit more complex. You rarely have to do that because it's generally not a thing. I should know. I need to double check. I forgot what is the exact command for removing from the staging area. Let me check. Give me 1 second. I think it gets a bit more complex. Generally, you just wouldn't add files into the staging area if you don't want them there. But let me see. I can't remember. Because what I would do is I would just revert back to another parts of the branch. But let me check. It gets a lot more complex than that. So here's what I'm going to say for right now is as we're learning, it gets a lot more complex. So on top of the staging area, there's also what we call stashing and all sort of stuff. It gets a lot more complex. We're going to leave that out for today. So just know that Git adds, and if you ever want to remove it, you can just delete the file and Git will add that, right? So what essentially we're telling you is you're not telling Git to add that file to the staging area, you're saying to keep track of that file, which means in the staging area, all it's doing is keeping track of that file. And what happened is if you, let's say, add things to the file, it'll keep track of it. If you delete the file, it'll keep track of it. And it just knows that this file is something I need to pay attention to and keep track of. Let's leave that at that for now. And if you're ever curious, you can look into it. There is a more advanced way to, let's say, remove something and so on and so forth. But okay, so now we have a basic understanding of Git init, which is basically initializing a local repository. You have a basic understanding of, let's say, Git commit. which creates a final copy. Git Add adds files to the staging area to be kept track of. So when you do a Git commit, it will actually makes a node in your branch, right? We're local, one branch. We're gonna shake that up a tad bit now. This is where it gets pseudo fun. It gets a bit more confusing, but we kind of have the fundamentals down now. So I'm going to clear the board. It's all gone now. So now we're going to introduce the idea of what we kind of talked about already, which is there being a server and it's hosted remotely. Sorry, water break. So this could be anything, right? So, and we're going to still introduce more ideas, but let's understand this first. So this, no, for sure. All questions are perfectly fine. What's the difference between benefits of using something like VS Code, where you save your code, and using Git Add commit locally? Sorry for the delay in asking. One, I do want to say Git Add commit locally. I'm assuming you're just working with a Git repository. What's the advantage of using something like VS Code versus a Git repository? Is they're a completely different tool, and they actually are tools that go hand in hand. What VS Code is what we call, there's two versions. The lighter version could be classified as a text editor, or also a code editor. So that is more ones that just have basic functionality. The more complex version or more tools built-in version is what we call IDE, which stands for Integrated, I can't spell, it's going to turn into this, Development Environment. And the major difference is this is just where you write code and everything is local. It allows you, it's not even where you write code. This is where you edit code and make changes to code. That's all you do here. The difference, what you're actually probably asking but not realizing, is this is just a tool, right? You can use this to work on both local files, which is what you're referring to, or Git repositories, which also could be local, right? So this is just a tool. VS Code is just a tool for you to edit and modify code. The difference you're talking about is just a local file. Let's say you wrote a Python file in your file explorer and just using VS Code edit it. It keeps the loses the advantage. It doesn't keep track of the lines, the edit history, different instances or snapshot of the code base that you might need to go back to, which becomes really handy in like actual development, right? So like this is generally fine if you're doing like a school project, something small where you only want to work on it and like you're working from remote. But when you're actually building, right, there might be instances when you write some new code, it might cause the application to break. When you're local, you wouldn't be able to have the features that keeps track of all the history and all the different snapshots of your code. So you would just be stuck here. You would have to undo all the changes manually. But what Git does is it keeps track of, well, a Git repository. It keeps track of different snapshots and history of your code, as well as who wrote it, when was it written, and it allows you to go back to different points in time as well if things break. You can always look at a code from before, right? So maybe I made a modification here. I want to reference at this instance, I can go back, right? And maybe let's say I want to revert back to this instance of the code base, but I want to look at what I did in this instance. I can. It keeps a complete history of all the changes you make, which a local copy of a code doesn't. So that's why you want to use a Git repository over just writing locally. And VS Code could be used in both cases because VS Code is what allows you to edit files that has code in it. Does that make sense? I'm going to take that as a yes. I'm going to move on to the next question. There's usually a terminal in VS Code where you do the Git stuff too, right? Okay. So we're learning a lot today. I don't want to get too sidetracked, but I'll explain this one. So you can think of VS Code, right? I kind of explained this already, is VS Code, the version you're talking about, most likely is known, I think both versions might have this, but remember, it's known as an Integrated Development Environment. Sorry for the shorthand, can't keep writing. What that means is it's just a program that opens up essentially a window that helps you integrate a lot of tools at once into one window so you can easily and quickly use them. And the terminal you're talking about, all it's actually doing is it's telling your computer, it could be Windows, Linux, it goes, hey, I'm going to say Windows in this case, right? Hey, window, can you open a terminal? And I'm going to take that terminal and put it right here. So that's what all it does. Essentially, it just opens a terminal on your local computer and goes, let me put it right here for you to use. So it's nothing unique, nothing special. And Git will be there because Git is installed on your computer, which is just the Windows terminal being nested in here. That's the word integrated here means. It's just integrating it into one whole window. Hope that makes sense. Yes, I don't use VS Code, so that might be the shortcut to bring up a terminal. I suggest you look that up. I don't know. I use the JetBrains ecosystem. It's free for students. I love it. It might be a bit more bloated than some with features that most of you probably won't ever need or use, but it's just what I use. VS Code is definitely a good one. I just don't use it, so I can't say for sure that Control plus tilde is for terminal. But that's all what the terminal thing does. Okay, now back to our bigger idea here at hand after a quick drink break. As I'm taking a drink break, I do like to interact with chat a bit. So, question for chat. Who is this their first Global Hack Week? Who's their first Global Hack Week? If it is, say something in chat. I just want to kind of get an idea. Who's their first Global Hack Week? Here, okay. We have one person, first Global Hack Week, and I do agree. VS Code is not my favorite, but it's definitely lightweight and it does work better in some. Nice. That's really cool. I'm glad. I understand the question. Is this your first Global Hack Week? This is my first one in hackathon. That's cool. Big distinction here. It's not a hackathon. A hackathon is when you have a certain set duration of time to work on a project and you just take all the time to work on it. This is Global Hack Week is just initiative that MLH, or Major League Hacking, runs every month. In the first week of the month, we run a week long of learning, workshops, and ideas. But this is not hackathon. You should go out to your first hackathon. But this is a good start for learning and stuff. I'm here. Nice to see you first time enjoying. Hopefully you're enjoying your time here. Okay, who has never heard of Git before? Like, whose Git is a whole new concept, all new, all brand new. That's fair. That's cool. Okay. Me? That's fine. Perfectly fine. This is a really, if you can get your head wrapped around this concept, it's a really, really solid start. That's pretty good. Introduce your friends. It's a great resource, especially want to get into the tech space. Even if you're not a CS major or non-technical, Global Hack Week is an amazing resource to get started and learn. I'm really glad to hear that. I love running Git because, trust me, there was a point where I thought I understood Git. I was like, oh yeah, I knew what Git is. Yeah, it does this and that. But until you fully wrap your head around it, it's a pretty hard concept. But yeah, okay, cool. With that being said, feel free to drop any other experiences, stories in the chat. I'm going to pick up where we left off, which is we explored the idea of Git being local and working as a local repository. So in that model, there's no server. We're now going to move to the model where this is where Git is the strongest and most powerful, which there's a server, right? Because what that allows is multiple people work on the code at the same time, right? Because if the code repository is only on your computer, I can work on it. I mean, you can work on it, but I can't work on it. But with it being hosted in a server that multiple people can reach, and the server can be your own server, could be the GitHub servers, could be the GitLab server, could be the Git, with Bitbucket servers, doesn't matter. So we're gonna draw this really simply. So this, okay, that was a bad box. Try that again. So this is our server, and it could be school server, it could be personal, it could be one of our cloud-based ones, CLOU, I can't spell, CLOUD, whatever, which include things like GitHub, right? I can't spell, sorry, or GitLab. Sorry, my apologies. Spelling does elude me at times. But yeah, so this is the server. Don't worry about it. Doesn't matter where it's hosted. Remember, just know that it's no longer local. I'm going to save that one for later. Don't worry, we'll get to that one. We'll save that for later. Actually, do you know what? I just discovered an amazing tool. I can actually start comments or revisit. We'll save that for later. I'll answer that towards the end when we take a break, and I'll go over that. Don't worry. But first timer Git was the bane of my existence for a time. This has made it much better. I'm glad. I love to hear that. It makes me. I love learning beginner workshop because of that. But yeah, with that being said, we're gonna take a look at this, right? So now we have a server. So what actually happened is you don't do this, especially if you use it. It depends. If you're using it on a school or personal, where you only have, let's say, a shell that has Git installed on it, you would then run like Git init on the server. And what this does is initialize a repository on the server. But if you use a cloud service like GitHub or GitLab, they have it packaged nicely into a button. All you do is you click, and it will run all these commands in the background, right? All you do is you click that button, you say you want to make a new repository. GitHub has an automation that goes Git init and types all the command essentially for you. It's like an automation platform. But just know, if you were on like a school or personal server, you might need to do Git init yourself. If you're on like a cloud or GitLab, when you create a repository, all it's doing in the background is running some Git commands for you, and it creates your repository. And they have some fancier like UI that you can look at and so on and so forth. But the ideas is the same, right? So now we have a repository in the server. So we can imagine, so here's our server, and we created the first node of our repository, the initial snapshot. And we're gonna call this root, right? This is the root snapshot, and we're gonna call this branch the main branch. You might see the main branch at times referred as the master branch, and that is it's as you'll it's it's the master, so it's like the most important branch. But due to some naming convention stuff that has been mostly obsolete or people are trying to stop using it because of some connotation might be attached to the word master. So places you can see still an older code base is maybe the word master branch, but most of the time we have stopped over to call it the main branch. That is just to clear it up. If you ever see master and main are essentially the same branch. It essentially is your root most important branch. It's your main branch. I don't know how to put it into other words. It's your main branch. Like when I say that, I mean it. I saw that it's in chat real quick. I'm glad this is your first Global Hack Week. It's a wonderful experience, and there's so much to learn. And I'm glad you have a minor experience. It maybe you're better off than some of us, but that's perfectly fine. Everyone can learn something new today. But looking at this, what this means is, so on the server, you have this. So you have root and you have main. Well, after it's been created, if you use something like a GitHub or GitLab, they might run some more automation, right? It might make a few files, like a README file. If you don't know, a README file is just simple definition of what is like simple description or definition of your program that you might want to write. But like normally it's like this, right? There's no files in here. It's just a bare Git repository. Now what happens is, let's say I am dev1. This is my local computer. This is my remote server. This is my remote, right? This is my local computer. So I'm on dev1. What I would do is, watch. So I have nothing yet, right? So I have nothing. What you would actually need to run, we talked about this command earlier, is called git, not pull. Pull is when you already have a branch, where you will have a repository. What you need to actually run is git clone and identifier to this repository. What that is saying is go to the server. I want to clone, which is make a copy of this repository for local editing. So it will just do this, and voila. Now I have my local version of this, and it's the exact copy. I have a main branch in my local version as well. I joined the hackathon last weekend and a bit struggle with the work with my collaborator in the same repo. That's why I'm here. I love to hear it. Having a good understanding of Git really helps on a hackathon project. If you have any questions, feel free to ask. I'm generally more than happy to answer any of those. It definitely is sick. Okay, let's go back to this, right? So Git clone allows you to take a remote repository and make a copy of the repository locally. I just want to remind you, this is not fork. We'll go over, once we go over fork, we'll go over the difference. This is not forking. This is making a clone of the remote repository. For the docs, can I refer to what documents? If you come on my slides, I will post them later. Unfortunately, I don't think I have them ready to post. I just need to make sure a few things are good with them and everything. And they're working live documents generally, but they'll be posted later. If you have any questions for that, I can explain things. Actually, what I will actually maybe share right now, real quick in the chat, is Git itself does a really good job of keeping documentation on this type of stuff. So I'm gonna drop the reference document real quick in the chat. So if you want to follow along or check things out as I'm talking, there is the Git documentation. Git also has a free book for you to use. This is a wonderful question, right? I was about to go over this. So let's say I am dev1 and I actually own the repository on the server, so I can make a clone of it. You cannot clone anything. Reason being is if you don't own it, you don't have the right to clone it. You can only clone things you have the rights to, which means there is an authentication that occurs, right? When I do a Git clone and I provided this repository, it doesn't just go yank. What it actually does is it goes, my computer will talk to the server and go, hey, I want to make a copy of this repository. Here's my credentials to make that copy. And if it fails, your Git console will just throw out error saying, hey, you don't have permission to make a copy of that repository. If it succeeds, it'll go, okay, here's a copy of the repository. It'll essentially download all of that down to your local computer and make it ready for editing. Hope that makes a bit more sense. But also, yes, here's a free book on Git. I've never read it myself. You don't need to read it. If you ever want to read it, you can. You can understand this all without reading it, especially when you start live doing it. We're just doing some fundamentals, and then if we have time, we're going to get some live demo in. And then this is just basic documentation. Documentation for any technology you're learning is important. I can't stress that enough. Documentation is always important. Feel free to go up, look at commands, read anything on it. This is really, I honestly say the book is if you're bored or if you really want to know every tiny detail, go ahead and read the book. Else, I would say I wouldn't bother, but I wouldn't bother. But yeah. Hope that makes a bit more sense. You cannot clone everything. You do need permission, right? So now I have a local repository down here. And what actually is probably going to happen now is I have a local repository clone. And let's say I want to work on it. But you never want to actually work on main. Because working on main essentially means that you're editing your most stable branch, right? Your main branch is the branch you want to keep the best version of your code. So I'm making edits and making modification. You could work on main, it's just not best practice. What you would do is you create a branch. So what branching does, if you remember from our talk earlier, is what it does is it says from this point, right? This is our root, so there's nothing here. It would say from this point, I'm making a branch off, right? It's no longer horizontal, it's vertical. I'm making a vertical branch off to this branch. So this was our main branch, right? This horizontal chain is our main branch. This horizontal chain down here is our new branch I just made. I'm going to call it, let's say, add feature. So maybe I make organ the calculator. I want to add, I need to pick better words. I'm going to call it subtract feature, sub feature. Because saying add doesn't make sense. So I want to add the subtraction feature. I can create a new branch called subtraction feature. And then this branch will start at whenever you branch off, right? Whenever you create the branch. So I'm going to go from here, branch off, start here. This will kind of look exactly like root, and this is your starting point. And what happened is then from this branch, you would get ready to connect to the next node. That doesn't exist until you do a commit. And what you do is locally, I might create like the files for it. I would add it, I'll stage it, and then I would commit it. And so once I'm done, maybe I commit it here. And doing the commit will then generate, let's say sub is now added, right? Not sub, it's sub is now added. And once I commit it, all the working changes I made to root is now going to be saved to sub. So this will actually have a copy of the code base with the subtract feature. If we look at this part with this snapshot, it wouldn't. Yes, great. So I didn't want to bring this up, but that's exactly it. So you would treat main as your production level branch, which means everything there is ready to be shipped off. I think I can't pronounce the second part, but yes, that's a good way, and thank you for bringing that up. That's what to actually explain it, is treat your main branch as your production ready branch, that like everything there should be ready to be shipped off, deployed, so on and so forth. And other branches where you actually do the work, you do work in progress with WIP, or you do testing and so on and so forth. So every works on other branches you create, where we call them feature branches, right? Because most of the time you're building a feature. And then Kit is fine. Amazing. Thank you. That is really helpful. And your main branch is your production ready branch that you want to be ready to ship off at any time. What is the best way to protect your main branch? Great question. You guys are wonderful. But I don't think I'm gonna get through everything today. But what is the best way to protect your main branch? We have something called safeguards. The best thing to do is most of the time you don't need to set these up because unless you're working on multiple level of environment, you don't need safeguards. But what you would do is you'll set up safeguard. For example, you might say, I as a developer, here, I will table that for now. We're going to explore that after we start looking at multi-developer environments. I'm going to first explain out this whole one developer creating branches thing, so we get that understanding. And then once I explain multiple developers, I'll get back to you on this one. Okay, cool, right? So now we saw how kind of this works, right? And now we want to explore is, okay, so now maybe I am done, right? I am done. I want to bring this back up into main. What happens is I would then want to do a git push, or first, that's a lie. First, I did a git commit, right? So a git commit is there. I did not lie, actually. I'm going to do a git push. What git push does is it takes a copy of your local repository and your branch specifically and try to pushes it up. So what end up happening is if there's no issues, it will go back up to the server and go, hey, I want to now copy all my work on this local branch onto the server. So git push only pushes the branch you're currently working on, right? So if let's say I add another branch from here, you would run git push for this branch, not all the branches. And once you run git push, what happens is you go to the server and say, hey, I want to make a copy of this branch. It's ready to be pushed up to the server. And what actually would happen is the server will go, if you have permission to modify the branch and everything, it will go this. And they go, okay, that sounds good to me. Let me make a copy of this. And it goes, okay, now the server will reflect your git. This is some weird stuff. Well, there we go. It's pretty, okay, that's good enough. Now with the git push, it will push everything you did locally onto the remote. So now we're going to delete that. So once git push is done, and let's say now this is on the remote and you want now this to be combined up with main, right? So I'm done directing, it's working fine. I tested it. It's all good. What then you would do is you run a git. Well, you wouldn't run git. Oh, it depends, right? So if you're using a cool feature, you would use what we call pull request. Right. So what pull request does is opens a request, and this doesn't exist in this doesn't exist in like your local or personal or school. Like it doesn't in your Git instance. The Git pull request is a feature of like GitHub or GitLab. We're gonna go over that real quick. Now we'll talk about how locally it will work, right? So this is the one you have, let's say, a Git repository hosted by either cloud service or a service that you're running yourself. And this is, you would make a pull request. And the pull request would say, hey, I'm ready to pull this branch here and make this the new starting point of main. And what generally happens is just through the pull request, people do code reviews, so someone maybe more senior or someone else on your team will look over your code to make sure it looks all good. And then if it gets accepted, or what happens is the pull request gets accepted, it creates a merge. It merges this sub into root and now points root here. And then this is what it will look like, right? And now after that, you can either delete this branch because this branch only has old stuff. If you're sure you can delete, you can also keep it. But what happens, you can just then delete this branch and you have this. And what you would do then is you would then pull back down to your local to get the most recent copy of all this action. And this is if you're working with, let's say, a service like Git or like a cloud service like GitHub or GitLab. If you're working purely locally, which some of you guys might, what you would actually happen is, again, I told you this before, a pull request is essentially just a fancier merge, right? It just says merge with checks and balances. What happens is when you do a merge, locally you would then move back over to the main branch locally. And then from the main branch, you would then merge your sub branch into your main branch locally. And after you do that, you would then push the main branch up. That's how you would do it. That's really all pull request is doing. It just automated it for you, but that's what's actually happening behind the hood. Yes, but you got to be careful of merge conflict sometimes. Yes, merge conflict happens when you are, let's say, Well, merge conflict really only occurs when more than one people work on the code. We're going to go over that a bit, so I'm actually going to start that. But I'm actually going to currently revisit this question now, is what safeguards in place, right? So when you're working with not like a service and you're working with just Git, the technology only, there's less safeguards you can put in place. What those services provide is those safeguards, right? Additional tooling that you're not writing Git commands manually, right? You're also not doing a lot of Git things manually. There's automation, there's additional tools and functionality built into those services, and that's not what only makes them valuable, right? Because I can just have a server that hosts Git repos on, right? Why would I want to stand up a service like Git T, or why would I want to use cloud hosts like GitHub or GitLab, right? The advantage of those is they have a lot of automation for certain things, like pull requests, what we talked about. And what you can do is put safeguards, right? So maybe I put safeguard in, let's say I have developer 2. I'm going to now generate developer tool. So this is another local. They're like, maybe this is my house, right? This is Kev's computer. This is, let's say, because you've been talking, I'm going to put Kit. This is Kit's computer, right? Kit is also a developer on this project, right? So what might happen is maybe I am the lead developer. And what I can put is I can write rules in, let's say, GitHub or GitLab or Git that says only the lead developer can confirm a pull request. That will prevent Kit from directly pulling her branch directly into the main branch. Another thing I can write is maybe nothing I would also write on top of that would be, let's say, as a safeguard is I would tell like GitHub or GitLab or Git is that Kit, the second developer, cannot directly modify main, right? Because what they can also do is kind of do what I talked about locally, even with a repository, right? You can bypass the pull request step by just modifying your local main branch and then push it up. But what you would write is saying Kit cannot modify the main branch. And that way, if Kit modifies and tries to push it up, she'll get a permission denied error, or they will get permission denied error, and so on and so forth. But that is the safeguard and stuff that's in place to prevent problems you're kind of describing. Okay. So now I'm going to clean this up a tad bit without erasing everything and kind of introduce a bit of infrastructure here already. Okay. So now we're going to choose dev 2 and dev 3. Okay, that's not a box. So in this environment, all of us will pull from the server. And all of us would just do the same working thing, right? We'll pull down from the server. We'll get a local repository of it. We're using Git clone. And then we would have, let's say, the whole exact thing. We'll create a new branch for ourselves, kind of like we talked about here, make edits. And then we'll push up, do the whole pull request cycle. Do the whole pull request cycle over and over again. And that's how that kind of all works. And then now we're going to talk about, I have any questions, please feel free to throw them in the chat. The difference between fork, right? So here is the repository where we're talking about. Here's the repository we're working with. What fork actually does is it happens on the server level, right? So maybe I want this repository. Maybe like I like the work that's been done so far in this repository. I want to build on top of it. What you would say is, hey, I want to fork this repository. And what actually happened is on the server, they create a whole new repository that then will just copy everything that was made in this repository directly over in this repository. And let's say we introduce, I'm going to call it odev. So this dev 1 is not a dev of this repository, but is the creator of this, right? What they do is they would say, oh, maybe I enable forking on this repository. I would say this dev will say, I want to make a fork of this repository. The server will create this, which then this dev will own, which gives them the ability to modify the actual repository and the code base within that repository. Hope that makes sense. So that's the difference between branches, right? Branches where cloning pulls something down locally. Forking creates a whole new copy of the repository owned by the person who forked it. If you have any questions, please throw them in the chat. I'm going to address this real quick. So merge conflict can occur when, let's say, dev 2 was, let's say, working on the add functionality, right? And I happen, maybe the subtract functionality uses something that that is shared between the add and subtract functionality. So maybe when they were doing it, they modified it a tab it. When I did it, I modified tab it too. There's a merge conflict is when the same lines of code, so maybe it's line 23, 24, 25, has been modified by 2 different repositories and you're trying to merge them together. It goes, wait, which one do I accept? And generally, you would just resolve a merge conflict by saying, oh, I want to accept this guy's or that guy's or that folks or that friends or XYZ. And then that will then fix all that and be fine. I'm going to thank you for asking that again. I do have that already started. I will go over that towards the end of the stream. I just don't want to get too sidetracked because there's a lot to cover. But yeah, that is the overall understanding of Git. Is there any questions that I need to whiteboard out? If not, we're going to move over to some live action implementation. Questions from chat. Okay, well, if there's no question, I will answer this question. I think I started. So what is the best SQL and non-SQL database to learn for a web dev and general coding project? The real answer there isn't one. The reason I say that is when you learn as a developer or as an engineer, I think personally, in my opinion, there's a difference. How I define it is if you're a developer, you write code, right? But you write, let's say, the application, the code, like that's a developer. What an engineer does is you write the infrastructure and all the technology and make sure they all work together, right? So an engineer's biggest question would be like, what is the requirement for this application? What does this developer need to use? What do you need to be able to do, right? And to answer that is to pick a different SQL will depend on what it depends on what your requirements are. Some common ones would be like MySQL, right? SQLite is a really lightweight one that might be used in web dev. But like if you're using a really big database, you might want to use like MySQL instead of SQLite. There's also MS SQL and so on and so forth. It really depends on the scope of your project. You got to do some research, figure out what is important to you, what feature, because not all SQL is the same. Different SQL they're really similar, but might offer a bit different feature and functionality. Figure out what you need and build from there. And that is advice I learned a lot recently, and I would love to pass that on. What is the best? Yeah. So for web dev, maybe look at like SQLite or MySQL. They're pretty. Postgres is like a really powerful one. You probably don't want to use Postgres, right? Look for things that are generally integrated with web things. Like if you're gonna be a Python web dev, right? You might look at what's the framework? Flask, right? I think Flask has like SQLite built into it and so on and so forth. So it might be something easy to learn. Yeah, sure. You're right. I forgot they just have it on loop. I wish I can get better background music. I can't, but good call. Here, we're gonna switch it up to this song, and let me know if it's better. Yes, my big question, if we have time, is what does good basic atomic commit tree look like? How small should a commit be? Okay, cool. We'll look at that in a second. I'm gonna start that. I'm gonna unstart this one. I'm going to look at this question. What are you going to teach in the next workshop? So I actually will be running a track. Real quick, before that, I'm going to actually have it down here real quick. Yes, there is data standards and so on and so forth. But yeah, I agree. That's just overall good. So there is this ANSI SQL, which is this set of standards for most SQL engine use. You can get pretty far with just learning the basic SQL for all SQL engines. NoSQL is more difficult to move to NoSQL. I fully agree. The concept, you do have to understand, SQL is a tool and technology, right? The overarching thing is the concept of database is a whole different thing. Essentially what you're saying here, which I fully agree with, is you can understand the concept of a database and how it all functions, the theoretical part, without even knowing SQL. SQL just stands for standard query language, right? It's just a language that queries a database. It's not even the actual database itself, right? The database itself is a concept. It has a lot of fundamentals, a lot of theoreticals in it, a lot of how things actually work. SQL is just a way to query an existence of database, and the different SQL engines are just implementations of the idea of a database and how it works. But thank you, Skull Crushers for life, I guess. You guys make me see some of the weirdest things sometimes. Okay, going back up here. So what are you going to teach in the next workshop? Next workshop, I don't know if it's fortunate or unfortunate. I'm running a stream every day. So next workshop, we're actually going to be teaching the introduction to Python. If you're new, it's going to be a 3-part workshop. We're going to first learn some concepts in Python, do some basic coding, and then hopefully end up with attempting to write your own Discord bot. This one will be a bit new one for me too, but it's a good way to build together. It's called Learning Together Python, I think is what I called it. You can check the calendar. It should be the Python track. And then I'm going to end it off with, I think on Friday, I am doing, I'm going to double check right now. But yeah, it's going to be called Let's Build Together, Python 101, which will first teach Python. We're going to build a few cool projects and try to build a Discord bot, which is like a really more in-depth how to use Python. We might, if we don't end up doing Discord bot, I might do something a bit simpler. It really depends on the crowd and where we're at technically wise. And then on Friday, so that's Thursday, Friday, Saturday. Tuesday, Wednesday, Thursday. It's going to be a part of each track each day. Feel free to hop in and join me on that. On Friday, I'm going to be doing Introduction to Cybersecurity, where you're going to learn a lot of concepts, start visualizing, theoretically understand a lot of this stuff. Hope that answered your question. I usually do plug my next streams at the end of my stream, as well as the following stream after me. So you kind of move that up ahead. But yeah, glad to have anyone join me for any of my other sessions. Yes, okay, we're going to answer this right now. And then I will write a few commands live, show you how it all kind of works. So when your question is, when is a commit, how big should a commit really look like? And that's a wonderful question. And my honest answer to you is, here's a question you want to ask yourself, right? So when you're writing things and developing, when should you commit? Once you make a working change is when you want to commit. Like, it's like breaking things up, right? Not every letter, not every word, but let's say I wrote a function, right? I wrote a function that successfully works, and that function, let's say, it performs the actual add, right? So maybe I'm writing Python. I wrote like def, add, and then like function, right? And this fully functions. This might be a good point to do a commit, right? Because in case anything happens, I want to be able to come back to here, right? But if you just wrote a letter, not worth committing. If you're just writing a word, not worth committing. It's kind of like saving, right? Commit as often as you can. Commit and push. Honestly, do both as often as you can. That way you commit it, so you create a save point. It's like a video game, right? How often would you save in a video game? You'd save any major checkpoints, right? So it's like creating a save point and then pushing it sends it to the server, right? So it's like a video game where you can create a save point, and then instead of maybe only having your save file for the game on your local machine, you also have a copy in the cloud. It's kind of how Steam works, actually. If you think about how Steam works, it works exactly like that. Just think of it as a video game. So here's the Steam server. I'm going to do a cloud, if I can do a better cloud. So this is Steam server, right? If you game, you know Steam. What happens is you download the game, including a local save file. So maybe I download the game, I don't know, Watchdog, right? This is just popped in my mind. Don't ask me. I download the game Watchdog. It has a local save file. I'm going to call save.file. It's not what you usually call locally. That it also downloads, and there's also a copy of the save file on the cloud, right? Steam, to make sure everything works fine, there's no cheating going on, right? You would play from local save file. On the save file, there is checkpoints you would save, right? You have save states. So those checkpoints are essentially kind of like git commits, right? You commit each checkpoint, and Steam will automatically upload this save file to the actual save file on Steam. That way, if anything happens, when you pull it down, if you download the game again with your same Steam account locally, you would have all that. And same thing for the same idea for Git, right? But for code, you would want to keep your remote repository as updated as you can. So in case anything happens to your local computer, you have the most up-to-date remote repository. You would commit as often as you want to create save points to be able to jump back towards. Yeah, exactly. Save before any major battles, major things, before you start anything new as a commit, and then push it up to the cloud. So in case your Pokemon game corrupts or your DS corrupts, or I guess, sorry, when I had DS, you guys have Switches or something. When your Switch corrupts, you can just get a new Switch. All your files are still there. Same save state, no loss. Any other questions? Questions, chat. Don't leave me hanging. Okay, it's okay. I'm glad. I hope that makes a bit more sense to everyone. And then I'm gonna look at the ones I bookmarked or screenshot it. So what happens if a separate user created their own branch and make changes, work within their own branch and not with each other? That works. Okay, so what that happened is that, okay, so we're gonna revisit this instance. I wish I started this one, I didn't. What I'm actually gonna do is you gotta see a really, actually I'm gonna answer this question first. Okay, where we went over forking and all that. Yes, for sure. Oh, that's funny. Okay, so we're gonna bring this question live on here because I couldn't pull it up the chat. So what happens if two separate users creates their own branch and makes changes that works within their own branch, but not with each other, right? That the branch itself doesn't actually run your code and make sure it works. What it does, the branch will cause a merge conflict, right? And then you just have to resolve the merge conflict. Okay. I'm not an encyclopedia for coding. There's things I'm strong at, there's things I'm low at, but graph theory and how could it be used? How can graph theory be used in coding in many ways, right? Graph theory, a lot of coding, you have to understand this. Coding is fundamentally built on math. Mathematics is the fundamental of a lot of things in our world, right? Like physics is just applied mathematics, right? Chemistry is also just applied mathematics. Most of them are on the calculus level, but they're just applied mathematics. So how does graph theory apply in calculus? In computer science? Computer science is just applied mathematics. So how can graph theory is, there is properties we have defined in graphs that we might want to use to maybe optimize algorithms, to maybe represent certain things, to connect dots, to make connections, make, correlations. And graph theory comes handy by when you take something and represent in the graph, you can also tap into the properties of graph. That's really it. Happens a lot in data science, data visualization. I have some experience in it, not my full strong suit, but simple answer. Are we going to do some hands-on with Git too? Yes. As soon as I'm done through some of this Q&A, we're going to pull up a replit. I'm going to send you a link to make your own account. We're going to do some hand commanding and then show you all this in live. And then we're going to call it a day because I'm tired. I'm just kidding. Let's see. What was the question? This one. Yeah. That's funny. Off-topic question, kind of. I'm trying to look at how to attend a hackathon for the first time. How should I go about it? Just find one and start making a project? Yes and no. It really depends where you're feeling. Here's my honest advice. I went to I don't know what age you are. Don't have to say it, and you shouldn't. Realistically, don't say your age. But I don't know how old you are, what stage of education. If you want to say your education, that's fine. But if you're, I started going I went to my first hackathon in college. But you can go anytime. If you're comfortable with going to an in-person hackathon, what you can do is look up MLH.io and then go to the top and go to hackathon and go to 2024 hackathon season. It's not up yet. It will be up on Wednesday. Once the NIT happens, where we do like announcing our season launch hackathon, which is our hackathon we're launching with this season that we're supporting. You can go there, and those are all physical. We do complete physical for at least this year. I think Ryan talked about it a bit earlier. Is doing complete physical hackathons for those, the ones we partner with. You can check there. So if you want to go to physical one, just go to MLH.io after Wednesday, go to 2024 hackathon, where that's only the hackathon we're launching with. There are always hackathon we're adding to that list. But you can look for a hackathon around you that maybe you will make it to. If you want to get started, maybe remotely, we do run our what we call first-party hackathons. It's a hackathon that's run by Major League Hacking. We run them almost every week. I don't want to commit to say every week because I can't be for sure. I don't want you to think I'm lying to you. I'm not. I think almost every week. And for those hackathon, it would be also at the same page. It will be at MLH.io. And then from there, you would look for 2024 hackathon. 2024 hackathon season. After Wednesday, it will say digital, and you can just join those remotely at your home. You can team up a few people and build a project remotely and submit those. And there's also prizes for those. Hack Week greater than Hackathon? Hack Week is definitely a learning experience. I don't know if it's greater than Hackathon. They're both amazing. I think Hack Week, if you're really new, might be the better place to start, and then take all the skills you learn and hop into Hackathon. Yeah, for sure. It's funny, but when it happens, what? Yeah. It's pretty funny. Yeah, there you go. And generally for a remote hackathon, especially the ones MLH runs, we have like chats that help you look for a team, right? You're like, hey, I have some experience in XYZ, or like, hey, I'm completely new, I'm looking for a team. And you guys can be a team of all new hackers. It's sometimes amazing to see what you guys can build and come up with. Okay, enough talking. Before I want to delete myself, we're gonna say goodbye to Paint. I'm gonna go back over to this for now. I want to move on to our next section of our amazing time together, which is setting up a replit. If you don't know what replit is, we're going to go over that too. Give me 1 second to get ready so I can have my replit up and sharing. you have any questions, feel free to ask. Yes, Replit is really cool. So I'm gonna now stop sharing that screen, start sharing a new screen, window. I need to look for my Replit page. There we go. Okay, cool. So I'm going to share that screen. So before that, I'm gonna drop in this link. Okay, so you guys can go ahead and sign up. Replit has sponsors in the past. I don't know if they're still current sponsor, but Replit is one of the supporters for Major Hacking. We worked with them in the past. I can't recall if we're still working with them, but they provide essentially, remember I talked about integrated development environment? They provide a version of that online. It's like a sandbox version where it's really cool because instead of having to figure out how to set up everything, you can just create a Replit account. Once you get a Replit, it looks like this. And what in here is you can create what they call Repel, which is essentially a sandbox environment that automatically installs all your packages, everything you need to be able to get started with development right away, right? So especially for new people, you might not know what language you like or so on and so forth. Replit is a really great place, right? So I can create a Replit on Python. It will install all the Python interpreters. So you don't have to do anything locally. It will set that all up. And all I need to do is get ready to code. So I'm going to start in Python. We're actually not going to be using any Python. I don't think they have a Git version. If I remember properly, they shouldn't have a Git version. Because it's not an actual programming language. So we're going to do Python. You can tend to do whatever language you want because we're actually only going to be utilizing their control whatever. We will be using this on if you do hop in. I should be using this if you do hop in. I'm totally blinking. To the last stream of Python. But right now we won't be. Right now we're just going to go into a regular repository. I'm going to name it Git Lessons. Now I'm going to hit create Replit. So this will create a Replit for me. In reality, we don't even want any of this. We just want the console. We don't want even the shell. We don't want main. It doesn't matter. We just want this console. And the reason why I want this console is... Hello? Oh, I meant we want not... Wait. Where... What? Oh, I meant I want the shell. My bad. Console. Sorry. You don't want the console on the shell. That confuses them because somebody looks in. So what console is where your program actually output stuff. The shell is where your actual terminal shell would be. Yeah. So you want to keep your shell. So in the ls, so yeah. So if you do a git to make sure it's installed, you can just do a git, right? You can see so git is actually installed. If you want to do this locally, you gotta install git. But git's already installed for us. So we're gonna check what version it is. I think it's a -v. Most things should be. It's not. It's a -- version. So we can check what version of Git they have installed on here. They have Git version 2.341. And I highly encourage you guys follow along. Head over to Replit, create an account. I'm going to pause for a second for everyone to do so. And we'll run through some of the command and creating a whole process together. It's going to be great. That is true, but hands down, I say it's really good for beginners to start sandboxing and playing with the technology to determine if they want to invest in it, right? So maybe they're deciding between languages. It's a great place as a sandbox to play around. Once you're ready and you're ready to develop, you can just pull it. You can pull down all your files from the Git, the Replit itself, the IDE itself, and you can just make sure everything's installed, or you can start fresh locally with everything installed yourself. It's a really good sandbox. It's great for lessons like this. Yeah, exactly. Anywhere, all at once. I will say, though, if you want, you can totally use Replit as a full development. You just have to pay some money and stuff. But you could totally use Replit as a full-on development environment. There's just costs to it, which I'm not recommending, or not recommending. I'm not providing any opinion on. But if you do want, that is the option available to you. If you don't have the Replit account, get one. It's great. Sandbox. Write something quick. All good. Runs anywhere. No installation needed. Wonderful tool. If you're wondering why I look over here a lot, is because chat's over here. By the way, I'm not. They're just like looking out in the middle of nowhere. Chat just sits over there. Yeah. There you go. I actually use Replit sometimes for live collaborations because Replit, if you don't know, it's pretty cool. I sometimes do an introduction to Replit. You can also do live collaboration. It's like a Google Doc, but for code. It's pretty cool. You code together, so on and so forth. Many people, you still use Vim when you instead for coding. I use Vim for coding still. Vim is my go-to text editor, but Vim is a command line text editor. I also sometimes run an introduction to Vim workshop. I didn't bring that for this one, maybe the next one. If you're ever interested, do join me for introduction to Vim. It's a really important thing to know because when you work on more legacy systems, or you're working on more when you only have a system with only command line, which is a lot of servers are just command line only, where they're called headless. Knowing Vim, which is a command line editor, is super important because it allows you to edit files. But yeah, it's good to know Vim. And I'm glad to hear that other people still think a lot of people use it. Yeah, for sure. Next time. It won't be this Globe Hack Week because I'm all booked out for this one, but next time. Yes, for sure. Okay, cool. I'm going to assume everyone has gotten it. Everyone's good. I had to disable InvestGuard to edit my code. That's funny. Okay, so I'm going to start walking through some stuff, right? So we talked about Git init, right? So first I'm going to do ls, which is, I also do an introduction to Unix. If you're not good at Unix, I'm sorry. The Windows version, real quick, Windows people, you can download Git Desktop, which will do it. But yeah, I'm gonna run some Linux command. I also usually do like introduction to Unix and Linux. I wish I could do all of it together, but I don't have that much time. I can't do, because that would mean I have the introduction to Vim, of introduction to what was this? Git, introduction to Unix, introduction to cybersecurity, and 3 other workshops would delete me. But yeah, so in the future, if you ever want, I might throw back in introduction to Unix, introduction to Vim. You can hop in and we'll talk a lot about it. But for today, just follow along with the codes, with the commands. The only ones you really matter is the Git commands. If you're on Windows, there's other ways to do it. There's also visual ways to do it. Look for resources. We're just learning the fundamentals. So I'm going to do it through Unix commands. I find it more complex to set up configuration. It's very and take a quick setup and start working. Yeah, it depends on what are you working on. If you throw me some things, I can throw something your way, and so on and so forth. VS Code and CLion. VS Code and CLion are 2 different things. I said I use a JetBrains ecosystem, so I don't use VS Code, but I use things like CLion, which is JetBrains C IDE. There's PyCharm, which is JetBrains Python IDE. No endorsement, nothing. I just personally like to use it. You get it for free as a student. If you're a student, get it for free. Woo! But yeah, long story short, short story long. Keep going, time. So ls just lists the directory. So I'm actually gonna make a folder. So don't even bother wondering. I think make sure it just makes a folder. So I'm gonna make a folder called Git demo, right? And I'm gonna change my directory into the Git demo. And I'm gonna do ls. There's nothing in here. So first thing. Yes, you should copy what I'm doing in the terminal. If any question, I'll answer them. I just won't be going in depth into every command because this is not a Unix workshop. But let's do this. You can enter everything I enter, right? So what I did is I checked my version of Git, number 1, make sure it's installed. I did an ls to see what directory we're in. When you do a git init, it will actually create the Git repository and all the information in that directory. So I made a new directory by using mkdir. I could call it git demo, call it whatever you want. And I then do a cd, which is stand for change directory. I changed directory, which means I moved into the Git demo. You see how my path increased by saying Git demo now. I did ls to make sure it's empty. Once that's all done, we'll do our first Git command. Actually, it's called Git init. And then once you do Git init, oh, I forgot. So you see, using master as the name for the initial branch because I didn't provide one. Doesn't matter. If you want, you can do configuration for stuff, but it doesn't really matter, right? So what we can now do is if we do Git, I thought we would do ls, right? We still see there's nothing, but that's because remember I told you when Git init on the remote or the repository, when you do a Git init, when you create a Git repository, it creates a lot of hidden files. So if I do ls dash LA, which means list all, you can see the hidden files as well, which you can see there is a folder called .git, which is hidden. So if I move into .git, and then you can see now, if I do ls again, there's multiple things, right? This is the Git actual framework and structure and how it's able to do all that black magic in the backbone, right? You have branches, config, description, head, hooks, info, objects, references. This is just things you don't even worry about. It's all the stuff. Oh, yeah, good call right there. Thank you for doing that. And do you know what's funny? Because of that exact reason, I have actually made my own. Oops, that's not good. Don't like that. I think I made my own version of one of these streams that hopefully. That's still not great. That's too small. Okay. Well, give me 1 second. Let me see if I can fix that. I'll just take out the comment. Well, I'll fix all this later, but I'll remove the comment for now. Okay, that's just weird. Okay, cool. I'm just gonna remove the comment. So if you have a question, you might pop up for a second. I'll take you off. But okay, cool. So I hope you can see now. I'm gonna blow this up a tad bit more if I can. I definitely can. There we go. So yeah, you can see this is all the stuff, the backbone, all the background stuff that's making Git actually work. So I'm gonna do a cd dot, which means exit by one directory. So I just went back by a directory, right? You can see there's nothing in here. Well, first thing we do is let's say I make a file, right? So I showed you Git init creates the actual repository. So now I'm going to show you is I'm going to do file. So I'm going to first do make. I'm going to do touch. What touch does is touch just creates a file, a new file. So I'm going to do touch apple.py, right? So now if I do ls, you can see now there's apple.py. But what we're going to do first is run git status, right? Status we saw about tells you what's currently in the what's been changed in the directory as well what's in the staging area. And you can see there's nothing in the staging area. There's no commits been made. And you can see untracked file is apple. That's apply. I'm totally crazy. Apply.py. What do you mean your total is 20? What do you mean what? Hello? I don't know what you mean by your total is 20. But yeah, you can see it's not in the staging area. So to get it in the staging area, well, real first, we're actually looking at the command, which is git branch. Br branch. Which shows you all the branches, which we have. Is it branches? No, it's just, I think it's git branch. Yeah. So git branch dash L, git branch dash help. Oh, so dash A. So I want to list, dash all. Okay, so there's only the main branch is what's going on. So git branch list is the branch, and because there's only the main branch, it's not listing anything. I'll show you when I make a branch, I'll do git branch again. But first things first, we're gonna do git status, and we can see that apply is not there yet. First we need to do is do a git. You can do a git add, then we can do add apply.py. So now if we do git status, you can see that git apply py has been added to the staging area, which is use git I guess git dash remove cache to unstage. It tells you actually. That's great. So you can see in the staging area, you can see new file git apply, right? So now if I do git commit, I will now. Oh well, you don't have to set this. It doesn't matter. So it does all that. That's great. So now if I do a git history, I think, or git dash help. I can't remember all the command. I just type them sometimes. Let's see. So it's git. Git log. So you see, your git log is master. You can know any commits because I didn't set. I'm gonna do a git commit again, but this time with dash f, or I'm a liar. I think it's git dash f commit. Okay, that's not it. So there is a way to force a commit. I just don't remember. Is it dash force? ORC. No, what is it? It's force. Commit options. Read from file. Commit. Oh, quiet verbose. Templated. Edit. Status. All inclusive. Okay, cool. So I don't recall. That's fine. Let's see. Oh, LSLA. Yeah, no, that's fine. Perfectly fine. Okay, so don't worry about that. I'm gonna do a clear real quick. So we did a git commit, but you saw the git commit fail because it doesn't know who we are. So what we're gonna do is if you do a git commit, if you ever need help with something, you can just I think git commit help will tell you everything that. Oh, so they actually removed it, but that's fine. So all you got to do is you're going to run a git config. It just you need to configure your files. So when you make a commit, it can actually keep track of who's making it. So I forgot you have to do this, but once you do, you only do this once. So I'm going to do a git commit email, right? So you only provide this information. So the git history can actually tell who edited it, their contact information, right? So I'm going to put a fake email. I'm not putting my real email here. At something.com. I'm going to run that. So now it's configured that as a global email. I'm going to configure a global name, right? So I'm going to do a global .name. So Git is really helpful. It tells you a lot of the stuff itself sometimes. I'm going to do like winter. And then, so now if I do a git commit, it will bring this up. Generally, it'll bring it up in the terminal as well. So essentially, you write a message saying added apply.py. And then you would then do save. So normally it will pop in the terminal. You'll just save. After that, save. the commit will happen, right? It says added a pod.py, and then it says one change, 0 insertion, right? So now if I do git status, you can see that you're on branch, nothing to commit because there's nothing in the staging area, so there's nothing to commit anymore. So I'm gonna do a clear. So I'm gonna do a git checkout, right? So we do git branch, it shows you all the branches because we made a commit, we have the master branch showing up. Let's say I want to work on another branch. I would do git checkout. I think I do -b. I'm gonna do add feature. So I first created the branch. -b means create the branch and move over to it. So I checked out into the add feature branch. So now if I do git branch, you'll see now we have both add feature and the master branch. And the branch we're on is the one that's in green and star. So I can do a git status. You'll see that this is also saying there's nothing. We can do a git log, which shows you all the log and changes that has been made, right? So it says when Turo with that email address made a change on, you can see it says from head to both these because they're both at the same location. Head essentially is just, remember the first node I drew earlier, I called it root. It's just called the head in this scenario. And it's saying that that leads to both master and add feature. Can you change master to main and git? Like in the naming, yes, right? So I can change the name of the branch. I think if I do git -- help, right? I'm going to double check. I think it's just git branch list record merge rebase switch fetch. There is a way to change it. I just can't recall. Git. There is a way. You can your assignment. I give you the documentation. Do some research. Figure out how to change it. You can rename branches. I don't know if it's MV because it's not a file. MV only moves files. It's not a file. So it's not MV if I know properly. I don't rename branches that often, but you can do some research and rename it. That's really it, right? So let's say now I am in so if I do git branch, you can see I am in the add feature branch, right? So I'm gonna I'm gonna use Vim. You don't have to. Actually, I'm not gonna use Vim. I'm gonna bring up over here, right? So you can see I was in the Git folder, but I'm gonna open up apply. I'm gonna write some code in it. I'm gonna write, hi, this is apply. All right, it's just dumb. I'm gonna save it, right? So now if I go back over here, I do a git status. You can see it went from nothing in the staging area to something in the staging area, and it doesn't say it's missing. It just says it's been modified. So I do a git commit. It'll be like sorry. Because we're in another branch and I modify it, it needs to know to add that changes. So when you work with, let's say, integral development environment, something to do this automatically for you, what you can just do when you do run git command, just do git command -a. It's saying add everything that's in the directory into the staging area, and then I'm going to do like add edited file, and then I'm going to close that out. It's now going to commit. So now if I do git status, you'll see that there's nothing in the staging area. If I do git log, you can see that now head points to add feature, but the master is now away from add feature, right? Head is what you're currently working on. So right now what I can do now is I can do git checkout master and do ls, and then I can do git merge, which is when you do a pull request, all it does is it git merge merge, and then I would merge in, let's say, add feature into the master branch. So right, for example, if I do ls right now, you can see apply. If I do cat, which is just prints everything out and apply. If I cat apply py, see there's nothing. But if I do a git merge, if I do a git merge, I'm going to merge in add feature, right? It now merged add feature into here. There's no conflict, so it didn't bring up any issues. So now if I do cat apply .py, you can see now it says, hi, this is apply. Okay, that's really all the demoing I'm going to do. If you're ever interested, I do sometimes run introduction to GitHub workshop, or we go into a lot more in depth. But I think we are going to call it for now. I'm here for any questions you might have, and we'll go from there. Okay, this you're doing a lot more than working with local branches, right? You can rename a local branch pretty easy. What this is doing is it's saying the git branch. So this is git branch move master main git push. So like this one is you're changing it locally, and you're also going updating your remote. Because we were just local, we don't need to update our remote. But yeah, this is good. Thank you. Appreciate it. I hope you enjoy me for the rest of my stream later this week. Again, I will be doing one on Python tomorrow and so on and so forth. Feel free to join me then. But we're not done for tonight. Right up next, after in like 15 minutes, we have introduction to, I think, IoT devices run by Vivita, I think. I'm going to double check that real quick. But no, don't go yet. Let me check. ML. Thank you. Appreciate everyone for joining me today. But please do stick around for our next amazing stream, which is going to be IoT track part 1. Join Vivita and her return of the Internet of Things track. Yes, do get some rest. Sleep is pretty important. And actually, if I get a chance to change my banner, I do this. So have a good rest. Have a good something, everyone. If it's not time where you are, get some rest. Hope everyone enjoyed the session. If you are wanting to attend the next session by me, it's going to be tomorrow at actually 8 p.m. Eastern time instead of 9. And I'm going to be running our Let's Build Python 101 part 1. And we're going to get started with Python, learning all that jazz. I hope everyone have a wonderful rest of your night. Do take care, enjoy. And again, remember, in 15 minutes, if you're up for it, do come back. But do make sure you get a rest. If you're up for it, do come back for Internet of Things. Now, have a good night, everyone. Take care.